Okay, in this week, we consider the measure of the network. You can find out many measure for the networks. Okay, uh, in here we uh, consider the degree distribution of the network and clustering of the network. Let's move to the topics. First is degree distribution. Okay, here is two network. One is bus network. Second is airport network. Uh, you can find out the difference between two network. Mm, uh, Actually, however, in physics or in mathematics, you have to introduce some measure to for the difference of two network. Actually, in the airport network, you can see this kind of a heavy connected network. However, in this bus network, in the United States, it has connection is very few. Even if this has some uh, many connection, however, their connection is very small compared to the airport network. Okay, then let's introduce the degree of the network. Mm, Degree is defined as the number of links connected to a node I. Here, we have a very small network having the total number of nodes is 5. I indicate each name of the node. For example, in node 1 has a degree, it means connected link. So it is connected 2 and 1. So you have a degree of node 1 has a degree 2, is 2. However, in node for the node 2, you have many connection. It connected to 1, 4, 5, 3. So it has a 4 connection to the neighbors. So it has a degree is 4. So you can find out every node. You can calculate the degree of the node. The adjacency matrix of this network is represented by this matrix. Then degree of node I is same as the you can calculate this sum of this element of the matrix for the row. For example, node I has a summation of these two value that is 2, so you can obtain the degree of the node. Okay, and then you can the degree distribution is a histogram of the degree. For example, I indicated here node 1 has degree 2, node 2 is 4, 1, 3, 2. Then you can make some histogram with for the degree, that is degree distribution. Here I represented it is pk. For example, you have only the degree 1 appear in this network only once. So you can define pk equal to 1 is you have a total number of nodes is 5, and you have only once, it is appear only once, so it is 1 over 5. So here I indicate pk as in this histogram. Similarly, degree 2 node is appear twice. This one and this one is the degree node 2, so you can obtain histogram like this one. And okay, degree 3 appear once, so here, and degree 4 appear once, so you have a histogram like this one. So you can plot the pk as versus k. It is degree distribution. You can obtain the if you have this degree distribution, you can find out some average of the degree. Average of degree is defined by if it is a continuous distribution, it is k of pk dk for the whole range of the k value. Okay, in this case, it is 2.4. It is average degree. Okay. You can represent the degree and nearest neighbor of the network. For example, degree ki means the degree of node I. Ki. You can use one-dimensional array of the degree sequence. So here, k list is represent first 0 element has a 2 degree. So you have a value 2 and 1. This one 0 1. 1 has a 4 degree, so it has a value 4. And 1 3 2. Then this list is represent degree list. Okay, degree sequence. Similarly, you can also represent the nearest neighbors by two-dimensional array. For example, here nearest neighbor I means a list of nearest neighbor of node I. So, for example, 0, 0, this is indicate 0 element of the nearest neighbor. Then it has this neighbor is 1 and 3, so it has element 1 and 3 appear here, and node 1 has a degree neighbor is 0, and 2 3 4, so it has this element is like this one. So you can list all neighbors of node I by this nearest neighbor two-dimensional array. Okay, right. For k equal 1 has n-1 node, so its degree distribution is n-1 over n. And for this one, with a degree n-1, so it appears only once, so the degree distribution is 1 over n. So star network has a degree distribution like this one. Okay. To represent the degree distribution, you can using the binning method. For example, I listed up a network has a degree represented by this list. It has a very diverse value of the degree from the 1 to the 100. Then you can draw the k value in the x-axis. Then these values appear somewhere in the k value. Some value does not appear. Some value is existing. Then to measure the degree distribution in this case, you can make some bin of this value. In this range, you sum up the all k value, and in this bin, this bin has the same length, same bin length. Okay, then put their value here. Then you can represent some value here. First bin is some representative value here, and you draw some pk in this histogram. Okay, so it first been in the range k1 and k2, and they don't overlap each other. It's been in separate with each other. In this case, you have 3 bins, and so second bin is k2, k3, third bin. Okay, you can find out the degree distribution by the histogram method in the NumPy package. It has given the calling is numpy.histogram. It has this is list of your degree list, and bin is number of bin. You can give a range. In the next page, I will show this method carefully. Okay. Actually, here is the example. In this 4 bin, actually our previous example of the small network is degree have this range. Actually, it has a maximum is 4 and minimum is 1. So we using the range 0.5 to 0.54, 4.5. Then if you binning this range by number of 4 bins, then its range is separated by this one, this 4 bins. First bin is 0.5, 1.5. Second is this one. Final is this one. Then in this range, you have some value located in this bin is only this one. So we have one in this range 1.5, 2.5. It is this one and this one will be for this range. Okay, you can make a histogram, and in here we use the k value as the middle of this range. So value of k equal to 1 has only 1, count is only 1, and in this range is middle is 2, so it is here is 2 is appeared twice, so it has a histogram like this one. So you can get the histogram of the this degree distribution. So okay, that is your degree distribution, and then let's move to the second topic. That is clustering coefficient. First one is a local clustering coefficient. Actually, I define the local clustering coefficient as like this one. Here, for example, consider first node. First node has degree is 2. Degree is 2. We consider the first node C0. Okay, then it is good idea to move to the how to calculate this clustering coefficient in the Python. It is CI, actually. CI is defined like this one. Then if you write down the CI here, EI is the number of connect node pair among neighbors. That is similar to the multiplication of this adjacency matrix triple multiplication. So it is similar to the you multiply a cubic and take the diagonal component II. That is your EI. So you calculate this one and divide by this value. That gives a CI. So you can apply this calculation. Actually, Python and NumPy can easily calculate the matrix. So in here, you can get the multiplication of the adjacent matrix and take the diagonal. That is a cubic II. And so you can get this easily the CI. Then for your example network, you can find out some this is clustering local clustering coefficient. If you get the every local clustering coefficient, then you can get the average clustering coefficient, average for this local clustering coefficient. Here is some network X function. Actually, the clustering means a triangle in the network, so you can check the number of triangle by this triangle module function, and clustering you can get the clustering coefficient of node. And okay, and average clustering gives the average value of the clustering coefficient of the network. Okay, here is some example. In this many example network, actually you can get the clustering coefficient. Some has a very huge value of the clustering coefficient like this one, but some network has very low clustering coefficient like this one. That means they are very different network structure. Okay, let's move to the topic of the path. Let's define the path. Path is a sequence of links traverse to go from a source to a target node. You have a source node and you have a target node. Starting from the source node, then you follow to the network link, connected network link, then you can reach the target node. However, in directional network, you have to follow the direction. So in some case, you cannot reach to the target node because direction is reversed. Then you cannot cross the link between two nodes. Therefore, there may not be a path in the directional network. In some cases, the cycle is called path, where source and target node are the same. So you can start here. You can visit some other path, then return to the same source node. The source and target is same. This is cycle, and simple path is on each link is only once. No traversing the same link more than once. Only you can cross the only once between two nodes. So we will only deal with the simple path. Okay, and the path length is number of link in path. Number of link in path. Okay, we define some definition of the path. Okay, for example, this is some example in 1736. Euler, a mathematician Euler, solved the Königsberg bridge problem. That problem was given his friend. that problem is like this one. In this Canis Berkeley, you have two islands, and here. Two island is connected by some bridge. It has a bridge 1, 2, 3, 4, 5, 6, 7 bridge. So some people want to cross this bridge only once and visit some other place. So their question was, can you cross all 7 bridges just once each? To solve this problem, Euler make this real map problem into some graph problem. He represents this place. For example, South Bank and North Bank as represented by some node like this one, and their bridge connection is represented by this link. Actually, this is first representation of the graph for the real problem, and Euler find out the answer. There is no ways to cross the 7 bridge only once. His answer is no, and most 2 nodes, start and end, may have odd degree needed to cross only once of the link. Okay. So for a given network, we wanted to path. However, there is many paths. For the path, we wanted to find out the shortest path. Shortest path between 2 nodes means minimal length between starting node and target node. For example, here A is starting node and B is target node. Then your shortest path is given here. It has a four paths is the shortest path. You can also go to like this one, but that is not shortest path. So in this network, you have a path, you have a starting and target node. Then you can find out shortest path. In the weighted network, you have to consider network the weight. For example, here I indicate the weight in here. 2, 1, 3 is weight of the link. Then this is the starting node. This is target node. Then actually to reach to the target B, you can follow this one, and you only consider the highest weight. You follow the highest weight here. Then it is this path is also shortest path of the considering highest path. Or if you wanted to lowest weight, then you have to follow this one and this one and this one. Okay. Anyway, there is 2 kind of shortest path: highest weight or lowest weight. Okay. Anyway, if you have direction, you have to consider the direction. For example, in here A and B, in this direction you cannot cross the E to the F by this is opposite direction. So in this case, you have to follow this one. So in the directed network, their shortest path is different to the undirected network. Okay, weighted directed network is similar one. And if you two network is unconnected, their path is infinite, is constant infinite. Okay. There is many methods to finding out the shortest path. That first one is called breadth first search. That is starting from the source node. That is called the root node. Then you find out their neighbor, starting the source node, and then the first node is indicate visited network. Then visit the entire breadth of the network within some distance from the source before you move to greater depths farther away from the source. So first you visit your neighbor 2 and 3, and in the next time you find out every neighbor all visited network. When you reach the first layer, 1, 2, 3 is already visited network. Then you find out unvisited network, 1, 2, 3. In this case, 2 neighbor, 3 neighbor, 4, 5, 6, 7, 8 is your neighbor of this visited network. Then the first reachable neighbor, this one is in the second layer, is your second target. So you connect in the second layer this node, and finally you can find out the unvisited network, this one. Then you can find out from the root. First layer has a shortest path length 1, and second layer shortest path length 2, and third layer shortest path length is 3. That is your finding method of shortest path. Actually, here is same diagram from starting one, and you find out your first layer here. Actually, in here, in this algorithm, each node has attributing storing distance L from the source. Initially, L is -1, except source equal to 0. This one is 0. So this one is source. All other is -1 length. And Q hold the frontier. Frontier is this one, neighbor of visited network. In this case, your Q is 2, 3, 4. And directed shortest path tree initially, all the node and the link. Then you can connect to this one. Iterate until the frontier is empty. If this frontier is filled, is visited, then you find a second layer, etc. Then this is algorithm to repeat, finish the iteration. And here I indicate first is in frontier is 1, second frontier is 2, 3, 4. Because here is direction, you can consider the direction also. In previous I shows the undirected network. You can also find out the shortest path for the directed network like this one. This is called breadth first search method. There is another method to Dijkstra algorithm. That is a method to find out the shortest path between node in a weight network. Here is you have a weight in each link. Here we wanted to find out least path with the least weight. So initially start with the infinite distance. You assign each node infinite value here, except the starting node. Initial starting node has value is 0. Okay, source node 0 for source node and infinite for all other node. And first, mark the current node as visited. The current node is this one is current node, so it is visited. I expressed the red circle, and then for the current node, consider all of its unvisited neighbors and update the distance. From here, you can find our neighbor, unvisited neighbor, that is 2, 3, 6. However, if the all node have been marked visited, then algorithm has finished, terminate condition. However, in this case, you can see one has connected first 2 because this is least weight. This is higher weight, so you can consider connect this one and their value, infinite value, change to their weight value 7. Okay. In next step, 1 and 2 node have an unvisited site. This one and this one, this one. Then check out the summation of the weight. For example, in here you can to reach 1 and 3, it has a weight 9. However, to get approach to the 1, 2, 3, it has a weight is 17, and this one is 14. So this is least weight. So you can express the this value, infinite value, change to the 9, lowest weight. So you can see 1, 2, 3 is visited value and their value is updated. And next time in here also you check their neighbor, unvisited neighbors. You repeat this process. For example, this one has checked. This connection is 14. However, you can reach this direction, and this direction is summation is 11. So therefore, it is the shortest path to reach the 1 to 6 because this weight is higher than the summation of 2 visiting 1, 3, 6. So your value is updated 11, and this is your visited node. The path length, shortest path length. You repeat this process up to the termination condition. Okay, this is called Dijkstra algorithm. You can accomplish the Dijkstra algorithm. I show some NumPy algorithm here. You can check this algorithm, and you can execute this program to your Python language by the Python language. Okay. Here I explain the meaning of each command. Okay. You can also using the NetworkX algorithm package. That is more easy. You can find out this clustering command or the shortest path length command. You can get the shortest path between the two nodes. Okay, next topic is average path length. APL means average path length and diameter. We can use the shortest path to characterize network. The diameter is defined the longest path length. That means the maximum of the shortest path length across all pair of nodes. So is diameter of network is defined by like this one. And average path length is the average of shortest path length across all pair of nodes. You have all pair of nodes is the possible pair of nodes is this number, and you divide by all adding up all node pair between starting node and target node. You can get the shortest path length Lij between two nodes. Then you sum up this value and divide by all possible pair of node. Then that is average path length. This is undirected network case. This is directed network case. Directed network case, you have no factor 2 disappear, divided by this one. Okay, what if there is not a path between one and more pair of nodes? You can say APL and diameter is undefined. So you can measure average path length and diameter within a largest connected component. Actually, in the network, you have some connected network. Some is this is the largest network, and this is smaller than this one. That is separated from this largest network. Then you can define the average path length in this largest connected component network. Then you can use the mathematical trick. Instead of the previous definition, we can use the 1 over Lij. Here is an unconnected network. Unconnected network, their distance is infinite. Then 1 over infinity is 0. So you have some adding 0. You have fine. So you can using this definition. Then you can also define the average path length like this one. Okay, here is LEDX comment. Here is path and shortest path length, directional case also, average shortest path length, etc. You can use things. You can try this LEDX function in your example network. Okay. Similarly, you can find out some graph D. For example, B and A. In this case, they cannot. It has a direction, so it has no shortest path. That is false. You should give a false result. Okay, you can use also weighted network, also shortest path like this one. Okay, this is LEDX importing method I already introduced to you. And another next topic is tree. Tree is looks like this one. Tree is a connected network without cycles, and the same definition is a tree is a connected network with n-1 links. These two definitions are same on, equivalent each other. In a tree, there is a single path between any two nodes. If you have a tree, you have only a single path like this one. Tree is called hierarchical. You can pick a node as a root node. For example, A, B is root node. Then each node is connected to the parent node. Root node is parent node. Then this is children node. And this is children node. However, this is parent node. So root has no parent, and leaves means termination, like this one. It has no children. So this is called tree. Okay, finally, let's check out about the associativity. Associativity means homophily. Homophily means a similar node became connected. Social influence means connected node became more similar. In this, if the network has some high homophily, it can also be a bad thing. For example, echo chamber or group thinking, a situation where your friends are like you. Diversity is killed, and you are only exposed to opinion that reinforce your pre-existing belief. That is called echo chamber effect in social science. Okay, so measure of the associativity is also known as it is called degree correlation also. So associativity network has a looks like a core periphery structure with a hub in a core. That example is a social network. Associativity network means similar degree node has connected to similar degree node. For example, here circle is degree of the each node. They are connected to each other. High degree node connected to high degree. Low degree node connected to low degree. That is a associative network. However, dissociative network has a hub to spoke or star structure, like internet or website, food web, bio network. In this case, hub is connected to periphery network, high degree node connected to low degree node. That is called dissociativity. In generally, in this kind of many network shows the dissociativity property. However, social network has a echo chamber effect. Is shows the associativity property. You can also measure the associativity or dissociativity by this function of the net x associativity coefficient. You can find out calculate this dissociativity measure. Try this function. Okay, the meaning of the associativity measure is defined by KNNI. You can also measure the KNNI is measuring another method, another way to compute the degree of associativity is by measuring the correlation between degree and average degree of the neighbor of node. That degree is defined by like this one. K and then K means node I has a degree neighbors. Node I have a neighbors. KNN means mean degree of the node I. For example, I have some neighbor J. This J has some degree also, like this one. Then you measure the your neighbor has a degree Kj. It has a Kj is 3. This has 2. This has 3. Then you average of this value is KNNI. That is KNNI. Then you measure the all KNNI for each node I. Then average. That is average KNN. You can also measure this value by the SciPy statics, like this one. You can easily measure this KNNI value and average KNN value also. Okay, this is challenging. You can think about this one, visiting this Wikipedia, etc. Okay, fine. I finish here. In this week, I introduced many measures of the complex network. There are many other methods I don't introduce. You can find out that in your the network science books also. Let's finish.